And then just to make that, I'm going to comment a little later, but as useful as we're up there, I want to talk about shadow puppets as a way to do some interface testing of it. So hold it in your mind. I worked at Microsoft for 5 years, so I am a member of the Informal Society for the Suppression of PowerPoint. So you won't be seeing me using it. Productivity destruction software. So I have some comments, and I'm going to show you some prototypes that I've used and talk about the way they were developed, and then close with some call to arms, if you will. In an ideal world, we developmental psychologists who work in the interactive industry would be able to test actual interfaces in order to get data on how children use them. However, as we all know, in the real world, the opposite is usually the case. Typically, if you work in industry, you are asked to evaluate or help create interactions that have never been seen before. So, for example, using speech recognition so the child can talk back to the doll. These are interactions for which there is no published research that addresses them, and for which there is no working prototype will be available to be tested until it is too late to make any changes. That's the nature of the industry. Now, a great many interface design blunders can be easily avoided with early formative research. The trouble is, how do you do the research when there's nothing to actually test? So my goal in these 15 minutes is to suggest some techniques for quickly mocking up interfaces and testing them, discussing some issues that come up when you do this, and sort of give you sort of guidelines so you can do what I call quick and dirty research in industry on your own. I want to start by saying why emphasize research at all? Okay, why would we bother to do research? Since I know many of the companies I work for don't. Okay, why do it? The reason I always say is it's because developmental psychology is itself an empirical field. Developmental psychology emerged specifically by challenging the conventional wisdom about how children learn and what they can do. And they marshaled research data to make their arguments. And it has remained a very empirical field ever since the field itself emerged almost 100 years ago. When I was in graduate school, the saying we used to have was, "In God we trust, everyone else has to have data." And I've lived to see great many theories overturned. So I'll show you a few ideas. So the trouble is that new interfaces raise a blizzard of never before asked questions that can challenge conventional wisdom. And they're only data, only actually seeing how they work with kids is a way to find out whether they work or not. Now, before I get into the details of that, I do want to make clear you can glean some answers to questions you have about designs by looking at the actual existing literature. I refer to this as parallel literatures. Okay, you're not going to find exactly what you want, but if you know the academic literature in the right area, topic, you can use that literature to really inform your design. Excuse me. Studies of social interaction and discourse patterns, for example, are a terrific resource for social interface design because they really give you the structure of social interactions and you really get to understand the structure of dialogues and things like that. And it's very useful for designing a social interface. For very small kids, as Kathleen and I work with little babies and things, you can get good ideas for the competence of babies by looking at standardized tests for them and finding items that seem close to the kind of task you're doing. You look up the norm to see what the age norm is, and poof, you have a data point, you have a reference point to go. I've worked on products where there are basic questions like, can 7-year-olds distinguish left from right? Okay, those are questions you can find out by going to the literature. You know, those are things that you can look at the literature on left and right and have your answer right there without having you ever talk about technology or computers. However, what I found is that some of the most important questions that come up can't be answered by going to the parallel literature. Because no precedent exists, and nothing matches that close enough to have any confidence that the results you're reading in the journal is going to matter to the product. You need to actually test the interaction. And this is where the real challenge comes, because you can be incredibly lucky, like Kathleen is at Fisher-Price with the Play Lab, and like I was at Microsoft. You know, you can have research facilities at your disposal. You can have kids ready to go. You can have the one-way glass, you know, the video cameras, the whole kit and caboodle. But if you guys don't have anything to test, what's the point? Okay, you know, all that stuff, unless you actually that's something kids use, what are you going to do? What do you do when that situation comes up? Well, I say borrow a trick from the interface research people who do the research with adults and fake it. How many people know what a Wizard of Oz study is? Okay, a little more than half. Really quickly, a Wizard of Oz study is where you have a human in another room, the man behind the curtain, who is actually pretending to be the interaction. There's somebody, a man or a woman, faking the interaction from another room. And so the person who's interacting is not actually using technology, they're interacting with another person, they just don't know it. And so that way you can simulate the interaction without having to have any kind of technology at all. You don't need any programming, you don't need any engineering stuff. All you need is the prototype, the dialogue. We've done this with the person who reads the thing in the same room with the kid, and it works great. They don't have to be in the other room. Well, obviously, if you're going to mock up an interaction like that in an interface, what you have to always remember is that you can't recreate the entire thing. It simply isn't possible. So when you need to create stimuli to conduct these studies, you have to start with what you're concerned about. What are the features that you, the developmental psychologist, think need to be assessed? And that's where you have to start. Because how you define what you're testing is going to shape the way you create your prototype, your mock-up. Okay? Because the issues you want have to be instantiated in that prototype. So you're going to pick the features of the toy, or whatever the product is, and try to put them in this prototype to test those specific features. The key is to focus on the developmental issue, not the technology. And a lot of times I found that's very hard for a lot of people to wrap their mind around. It is not important if the talking interactive doll is really running off of a chip where there's a guy in the other room with a microphone and a script. Okay? From the point of view of the interaction, it doesn't matter. And you can get a lot of really good data about interactions by cheating that way. What's important is that the interaction that you set up to do this emulates in your study all the pieces that you need to test. So like for script, when I do it with language and scripts, we look at things like the timing. The guy with the script sits there with a stopwatch and says how long you wait 20 seconds before he does a prompt. You know, we have a little flow chart so when the kid does something, they know how to respond. If you're concerned with timing, if you're concerned with vocabulary, that's the kind of stuff you put in your prototype. The rest of the stuff you don't have to worry about because you don't have you're not concerned with them right now. So here's my principles for getting this done over many years of experience with the Whitmarks agreement. First, understand your schedule and understand the development process of your client. This is the single biggest challenge you're going to face as a developmentalist trying to do research in the industry. How much time you have and where in the process you get to make changes to the design. Usually, you've got to be started with research right at the very beginning when the product is just being formed. And the reason for this is that the nature of technology manufacturing is such that the intelligence, the interactions, have to be completely finished because they're a component that goes into the finished product. So that component has to be done and be being manufactured long before it's ever put into the product. So having to answer questions about the interactions, you have to work fast and you have to be upfront because the timeline for getting any changes into the ROM or whatever the interactive core you're using is very small. They'll want it locked down very early. In some cases months before the product actually rolls off the assembly line. Excuse me. So you have to make sure that you understand those deadlines. Make sure you understand the development process. Every company's development process is a little different. It took us a very long time to wrap our heads around Mattel's development process from Microsoft because it was so completely different from our own. And when you do sort of get a sense of this, what you have to do is understand your deadlines and then make sure that everybody else who's supposed to use the results knows the deadlines too. Make sure everyone agrees. These are the places where you make changes. That saves you an awful lot of headaches. So, if you do a study and there's a horrible mistake and you missed a deadline, too bad. So it's important that everybody on the team, the guys who have to implement the changes, the people who test the changes, that everybody knows when they're coming. Second, you have to define your research questions in very specific terms and avoid mission creep. I have found nobody wants to pay for research, nobody wants to fit into the schedule, but everybody wants a piece of it if you actually manage to get it done. The marketers will want to know about it. Your boss will have questions. The engineers will have questions, which will probably be different from yours. And to the degree you can, you should try to answer these divergent questions. But this is where you have to be careful. Typically, the broader the set of questions you have to ask, the more aspects of the interaction have to be built into the mock-up. And so the mock-up starts getting complicated, or the testing protocol starts getting really complicated because you're trying to answer so many different questions. Excuse me. And you have to avoid, so you have to be careful and avoid the fact that when it becomes too clunky. If you're working without technology, like you're doing a man or Wizard of Oz study, okay, there's a limit on what you can simulate and test because the man behind the curtain can only do so many things. So you have to keep focused on your questions and make sure that those are the ones that get front-loaded, because that's what you're being paid for. Now third, when it comes to actually creating your stimuli, I have two recommendations. My first recommendation is think pretend. And I say think pretend because remember, your focus isn't the technology, it's on the interaction. You're trying to fake it, test the interaction, as if it was coming from a computer or toy or whatever. And pretend play is all about as if. It's about maintaining two levels of representation at the same time. I know this is a doll, but I'm going to pretend it's a baby. You know, let's pretend your sister is a lion. You know, like, I know she's not a lion, but let's pretend. And kids do this like that. It is incredibly natural to them. And they will put up with a lot from a pretty crappy mock-up just to play along and because it's interesting. Knowing that, and for example, because they play along, a lot of things like a puppet, reading your script, your character's script to your kid, and seeing how the kid responds to questions and answers. Really easy to do, involves no technology, and kids play along with that. They love that. They love interacting with the puppet. You answer a lot of questions that way. And even if it's not a dialogue, anything you're going to set up, you can learn quite a lot by playing that simple duality. I know this isn't what it is, but I'm going to play along and pretend, because it seems like it might be fun to do. My second piece of advice if you're designing prototypes is to suck up to your engineers. When it comes to creating your actual mock-ups, your engineers can be your best allies. Often they've got pieces of the games, art, or code, or even physical prototypes that can be used in your mock-up. And much of the time, they're as interested in the research as you are, and they really want to help. So if you're working with on-screen content, there's a million different easy ways to mock up Flash prototypes and test real substantive on-screen content interactions very easily. If you have a physical project, like the ones that I've been working on for the past 3 years, things start to get really interesting. And that leads to the next point, when we talk about prototypes, in a minute. Don't let the perfect be the enemy of the good. Your prototype is going to be different from your final product in a lot of ways. The voice may be wrong, it might not be the right character even who's going to be in the final product if you're using licensed characters. Just a quick example, when we did our first interactive plush at Microsoft was Barney. Then the next set of interactive plush was going to be Arthur from the TV show on PBS. And DW, we wanted to test with older kids. But we had no prototypes to work with. We didn't have anybody who could fake their voices very well, which accounts for a lot, trust me. So what we did was we had an old Barney, an interactive Barney, that had been modified for earlier testing, so that you could shoot your microphone and it would come out of the character, and you could move, make it look like it was. So what we did was we dressed up Barney. The kids that age hate Barney, right? So we got a leather jacket and a backwards baseball cap and a muscle tee. And it fit on the doll, and we put them on the doll, and we introduced it to the children. We brought it, and they say, "Who's that?" And they say, "Well, that's Barney's older brother, Blarney." All right, it worked like a charm. We played all the games with it, and they loved it. It was great, and we got all sorts of really useful information. And it wasn't R3 to DW at all. So the fact these things don't quite match up doesn't necessarily threaten the validity of your testing. Remember, if you're focusing on the interaction, the specific features of the interaction are what you want to test. So don't worry about that the prototype can vary rather strongly from your final product. As long as it embodies the elements you want to test, that's great. I'm going to move over here and just show you some prototypes. I'm one of the weird people who doesn't throw them away at the end of studies. I keep them. Because I love them. You could really test your prototypes. So I'll start here with Barney. Here's the first prototype we used. Okay, this was the only Barney plush big enough on the market that we could find. And of course, here's the tether, because of course he didn't have any intelligence, but he could simulate the interactions from the computer. We sewed sensors into his hands and feet, just like we were going to do for the actual plush, and we bored a hole here and put a light sensor for his eye, because Barney plays peekaboo. And so this was the prototype we used to test, tethered to a computer. There was also a motion sensor. We ended up dumping it, and this research showed us why to dump it. So this was the prototype, and here's the final product. They're relatively simple. Now, our Teletubbies is one of our later products, and the master toy license for the US had not been assigned when we went to do the research. So there was no product to go to the store and buy and then come home and hack. So when we were in London doing the negotiations with the Teletubby people, we stopped at the toy store and bought the biggest Teletubby toy we could find, which was Tinky Winky at that time, because he's the biggest overall. And there were the engineers who sewed in the sensors and put the intelligence in a little box here. The EEPROM is corrupted. I was hoping it still worked, but it doesn't still work. they glued these screens on. These are two demo LEDs, because he has an LED in his tummy, or LCD LED thing in his tummy. This is a mock-up screen we were going to use. This was not turned out not to be the right dimensions for the screen in terms of the number of dots. Doesn't matter. It still allowed us to do testing. When we took it out and tested it, because of the wires, we made sure that it was seated. We didn't let the kids hold it, which we would want to do with the actual product, because it's a soft plush. But because of the cables, we couldn't let kids really pull it up from this pillow. So we had a place where we told them that it was delicate. They had to leave it. What we found in the research was every time you brought this doll to them, you would say, "How do you think you can wake me? You think you can get up?" Right? And every kid goes, right? And there was no tummy sensor. So the engineers didn't want to do it because they were worried about leakage, liquid leakage and things, and so they didn't want to do it. But 100% of the kids, every time he picks up. So I brought videotapes and we all sat down and I said, "Let's watch this too, John." So we watched all the kids pushing on the tummy all the time. And so the engineer said, "We give up." They went off and they found a way to make it work. And so of course, how do we test that? Because they couldn't put the sensor in here because there wasn't a way to make it really reliable. So they gave me a wire with a little switch. And so I would sit there with this cable snaked around here, and whenever the kid pressed the tummy, I pressed the switch. And it worked like a charm. The kids were out there pressing the tummy. And then this is the final product. It must be I didn't fix his batteries. 5. Okay, good. Just for comparing, I know Paul has batteries. So this is the final screen that we use. The speaker's in there. Sorry. That's what was unusual about it. Now, then finally I want to talk about, so these we did at Microsoft, and you can tell the engineers, fingerprints are all over these, right? The engineers wanted help, they were pretty willing to invest extra time, so we had some awesome prototypes. When we worked with Fisher-Price to develop the IntelliTable, the way Mattel's design process works was that we could not come up with a prototype, and our engineers were very reluctant to create prototypes for babies to play with because there was no way to make them safe enough. So we ended up not doing actual interaction, very much interaction testing, simply because the engineers were very uncomfortable with having a drooling kid interacting with something with batteries and wires, and So we said, let's not do that. And they also tend to be pretty rough with things, and the prototypes tend to be fragile. But Fisher-Price is, I wouldn't call them a hard goods company, but the toy tradition at Fisher-Price, until Interactive started doing their products, was very physical. It was all about the actual toy, and they do a lot of mock-ups of the actual physical toy that they're going to have. They pass it around so you can feel it. And this, there are three rings that go on the IntelliTable. We call this the mothership. So too much time in dark rooms with engineers. Fisher-Price was curious about these knobs. There's a twirly knob on here that when you turn it, it makes this display cycle in time with the turns back and forth. We were trying to go for an interactive busy box. A digital busy box was the concept behind the IntelliTable. But we didn't know about these dials. A lot of other products existed that had sliders and things that we could test, but the dial was a pretty rare commodity. And we were concerned because young children's grip, the way that they grasp things, is different than the way that we do. And we were concerned they wouldn't be able to grab it and do the right turning thing with it very easily. And we wanted to encourage them to spin it, which turns out to be a little hard. And at Microsoft, we had a lot of ergonomic people. The ergonomics people were very concerned about the ergonomics of this for small hands. So Fisher-Price, the people at Fisher-Price, sent us a mock-up of 3 buttons. There are 3 dials that we were going to use. And we took this out to preschools and had kids twist them, so all they did, did they put their finger and spin, how they, and so we tested each of these with kids, and this is for each of these different rings. And for each one, we ended up making slight changes based on the research. So just for example, this one has 4 sort of things to grasp. It turned out that for little hands, that was too cluttered. So in the end, we have 3 of this one. And the little finger holes turned out to be awesome for having the kids put their finger in and spin. But this one with this lip is a little too deep. It was not quite right. So if you look at the product now, you'll see that each of these is slightly changed based on this research. And then as old-fashioned I am, right? I said, oh, I'll demonstrate my iToy testing protocol by casting a shadow. Oops, wrong technology. So a project which we did not do because the company I was working for didn't want to fund it, and I think thing that shows the final product, was with an iToy type toy for preschoolers. And when they first were talking about this, I said, oh my God, there's so many questions about this, but I do not understand, that we do not know the answers to. And the regular iToy products on the market are just too fat and too sophisticated for preschoolers to use. And so we said, okay, the existing iToy games don't cut it, but we need some way to test kids during this virtual interaction. And so I said, shadows. Get in, we're going to, so I submitted a research proposal where we get an overhead projector, shine it on a wall, have a piece of acetate you can draw little objects on, and then have the kids stand in front of it so their shadow is in the environment. And then have the kids use their shadow to touch the virtual objects. We could move the acetate back and forth and see how fast it could move and let kids touch it, things like that. Of course, that, even though that was extremely cheap by the comparisons of that kind of thing, the company didn't want to do it. Now, back over here for my conclusions. So, it's my last thing. 1 minute, okay. Don't work it. So, last thing, document what you did and your conclusions. Now, I know this is a pain. Most people think it's bureaucratic paperwork, all right? But trust me, people will challenge your results, and you won't remember. Or later on, you'll wish you knew because another product from the same client is going to be based on some similar principle, and you didn't write it down and you forgot it. So take the time, your expertise, your vitality, what's going to make you valuable to industry is your expertise on this, your accumulated wisdom. Okay? Take the time to accumulate your wisdom. So in conclusion, what I'd like to say is issue a call to arms. Right? My fellow developmental psychologists, lend me your ears. We in industry have to reclaim our intellectual heritage. Become the in-house scientist that quality product development for children requires. Be creative in your methods. Document your results. Good developmental design is a combination of wisdom and testing. We need to be creative and quick if we are going to act as forces for good in a fast-paced industrial world that is happy to take money from our children and give them crappy products in return. Thank you very much.